how's it going? Welcome to this video. This is what I've entitled Inter-VLAN Firewalling. Basically, it's following on from my other videos I've done recently about VLANing. This is about how to, so I mentioned before about the concept of VLANs, how they're layer 2, and in all of the communication between those, you need to route them. So hence router on a stick. But this is going to be a really overview of what is known as the forward chain within MikroTik. We're going to use that to basically allow and initially deny traffic. So if you look on the left hand side of this topology, we've got what is my setup, which I had for my VLANing one. So I've got my router here that's connected to a switch, which is Cisco, but we're not actually going to look at the switch today. And that is that's a trunk between the two. And VLAN 30 is an access port on this interface for one of my test machines. And then on the router itself, I've got an access port set for my other test machine, which is VLAN 20. Now to sort of show you some more, other than what's just happening in this single router, I've joined this other router to it. I've set up BGP between the two, but again, if you don't know much about BGP, don't worry about it. Just need to know that it's advertising these two routes to this machine and then this subnet to this one. That's all I'm doing, so keeping it very simple. It's just because I'd rather do that than configure static routes. And then over here I've got a Linux machine which I've just installed Apache 2 on, which I'm going to call my Webserver, although it's not actually running anything fancy. But what I'm going to attempt to do, or what I'm going to do, is set up the forward chain here to only allow access from this machine. I'll deny it from this one, and then what I'll do is I'll show you how we allow a single port effectively, so just allowing the HTTP access. So there's nothing to do with port forwarding here. We're literally routing everything. This is all an internal network. We're not worrying about coming in from the outside world. So I have done other videos about port forwarding, so check those out, where you would take your public IP address and you would then effectively NAT it on behind to point it to an internal IP. But this is all internal networks. And then on this one, what I'm going to do is going to show you how you control the access between these two subnets as well. So these could be different clients. One could be your corporate one, and one could be like an IoT or management, and you only want to allow certain access between the two in certain directions. And that's pretty much it. So network, I've got 3 networks on this one. One being my basically my development network, which is joining these two together. My test 1 and test 2 subnets, and over here I've just got 2 networks, and they're directly connected to the interfaces themselves. So without further ado, let's get going. Okay, so here we have my router. This is the one that's connected to the switch and has the 2 user VLANs on it. So please check out that other VLAN video I did if you're unsure about how this is working. But this is effectively turning those layer 2 VLANs into layer 3. So we're sticking IP addresses on them and we're allowing the routing between. Routing is very simple. As I mentioned, we've got BGP running, which is just advertising me that route from the other router, which is where my Linux web server is sitting on. And then we just have the 2 local users there. Upstream network, I've called it WAN, that's going to basically the development network, which is where it's talking to the other router. Then we just have a default gateway over there. We jump on the other one. Again, I'll show you the same thing. We've got just the 2 networks on there. I've called it DMZ. If you don't know what DMZ means, it's not really anything to worry about. Basically just means it's segregated from, we try and keep that separate from the rest of the networks. IP addressing, again, I've just got the 2. This is the gateway for that, what my web server is sitting on, and then that's just again my linking to the corporate network. This one has no default gateway, so it won't route outside of the networks it knows about. And we get an IP routes. Sorry, no, it does have a default gateway. I was looking at the wrong thing there. That was not the routing table. It does have a default gateway, but yes, we're not routing we're controlling the routing and where it's going to go. And then, as you can see, I'm getting these two from my other MikroTik. Okay, so hopefully that's all clear. Rewind to look at that topology again if that helps. But yeah, we'll crack on. So I'm going to start on this side, on the web server side. What we're going to do is we're going to start to control the access for the devices accessing the web server. So we start on Firewall, where we first tab filter rules. And as I've done a video on firewalling before, and I was concentrating on the input chain because I was trying to explain keeping your MikroTik safe from the outside world, from the internet. So anything input chain is anything destined for the device. Forwarding is anything going through the device, which is what we're doing. And the output is effectively anything generated from the device itself going out of one of the interfaces. So the forward chain is the one we're looking at now. And with all routers, their primary goal is to route traffic. They're not a firewall inherently, so things like a FortiGate or Palo Alto will have an explicit deny rule in there, and then you have to add in so you have your wall and you have to poke your hole through your wall to allow your traffic through it, whereas a router will just by default just route everything. So what we're going to do is create that explicit deny rule. So we're going to lock it down to particular interfaces. So we want anything coming in from basically the corporate side, or I've called it the dev side, so the internet. It's not really internet access, it's just where it would route to the internet. In fact, for simplicity, let's change that to be WAN as well, like I called the other one. So it's a wide area network. There we go, so it's now changed. And then this is going to our DMZ, and we're going to action drop. So now we have our deny rule. So effectively everything, and in fact I'll just disable that. Oh, I forgot to mention, yeah, I've got my two hosts here, which I'm accessing through a separate management NIC I've got connected. But again, there's no, which is on that development network, but there's no gateway. So these will always try and route this interface, which is the one that's connected to the MikroTik. So on those two VLANs. So if we do ipconfig, I've got 20, which is the first one. As you can see, it's got a gateway there of the MikroTik. And then if I do the other one, ipconfig, there's on, so it's on VLAN 30. So we open up this, we go to the IP of the of my Ubuntu server running Apache 2. This is just a default page you get when you install Ubuntu. I haven't done anything to it, but it's just showing that you can now access it. And we can also bring that back up. We can also ping. Okay, so we've got full access to everything. So let's just go ahead and enable our deny rule again that we just created. And try that same test again. Ping stop. This may be cached if it just load. Let's try it on incognito. Okay, yeah, so it's not loading. So what we're going to do is we're going to allow everything from this host, and then we're going to only allow HTTP from everywhere. So let's start by allowing everything from our individual subnet. So there's two ways of doing this. We're going to do it because the interface, this network doesn't reside on an interface on this router. We're going to match it based on the IP range. So we can either do, stick it in here. Okay. And then we're going to do coming from, again, from WAN to DMZ, and then this time we're going to do accept, and we just need to make sure that gets moved above because they work top down. As soon as it finds a match, it applies it and doesn't follow on anymore. So it will run for every single one until it gets a match. If it doesn't get no match, that's when it hits this explicit deny. So now if we go back to this one, we should be able to, although we didn't test on this before, but it would have worked. So that's me, I'm pinging. What am I on? 172.16.1.254. Okay, that one works from there, and again, still should be broken from ping. Okay, so it still doesn't ping from there. Or like the web page. Okay, so next thing we're going to do is show you the other way of doing this. So instead of using a source address, so this basically means that we can, if we wanted to add the other network as well, then we would have to copy this rule and then just put that subnet in there. However, I like to keep things a bit neater. So we take that range, we copy it, we go to our address lists. Ignore this, this is basically me. This is how I'm advertising my routes out, hence why it's called BGP. But we'll create a new one called allow web server. It's basically anything allowed to access the web server. Stick it in there. Okay, that. Now we jump back on here, we take away that, and then we go to the one where it says source address list. You can see it's now created it there. We okay that. Confirm that it still pings. It does, and then what we then do is if we wanted then to add another one in, so we just copy that. That's in there. You can drop down or you can type it. If you type it and you get a character wrong, it's just going to create a new list. So it's best just to copy it. If we add that 30, so the other range, so we've now got both of them in there. We jump back on here. Oh. Seems I've lost remote access to that machine. Try logging in again. There we go. I've got lots of command prompts open for some reason. Okay. Right, now we're on the second one. So you can now ping it again, and it's loaded this in the background. Okay. So hopefully that makes sense. So now I've applied an address list, and then I add my lists here. So one rule, but has multiple different. I can then just add and remove as I want without having to create multiple. So you don't fill up your table with heaps of identical rules. So we'll take away this guy. Okay. So now what we're going to do is we want to allow. Just if you do ever click on this, it's going to sort them, and it's going to look like that is in fact above it, but it's not, because we always base it off these numbers here. So 0 and 1. So 0 is always at the top. So let's go ahead and add another accept rule. So we want to add anything again, same interface. You don't necessarily have to specify the interfaces, but I just like to keep it as granular as possible, because we could have lots of different, other interfaces we don't want to affect this on. So we're going to actually specify now HTTP. So the protocol, so you've got TCP or UDP, got all the other ones in there. ICMP if you wanted to allow ping. Destination port, so it's always where the traffic is going to. So as it passes through, it's going to match on where it's going to. So we want 443. Okay, and then action accept. Again, we just need to make sure that goes above there. Okay, so as we can see, we're allowing everything from 20, so that won't hit this rule because it's allowed there anyway. But we should now, back on here, ping should stop, which it has. And then let's just do that again in incognito, so we don't get any false positives. 16.1.254. Make sure it's trying to load HTTP, yep. Oh, you know what I did? I've done 443, haven't I? That's HTTPS. There we go. Boom, there we go, works. Hopefully that makes sense. So now what we're going to do, so that is dealing with external networks. passing through our router. So now let's go ahead and look at routes or traffic that's coming from this, that it resides on that router. So we'll jump on our other one, and we're going to talk about these two VLANs here, 20 and 30. So let's bring up our firewall. Okay, and now we're going to start with our explicit deny. And for this, what we're going to do is we're using interface lists. So we're going to, instead of having, we could have a rule that comes in from that destined for that deny, and then we could have the reverse. But then what happens if you've got, like, I don't know, 10 VLANs you want to control? You could have deny from anywhere to anywhere, but again, we want to allow our internet traffic still to go out. So what we're going to do is we're just going to accept. We're going to interfaces. We're going to interface list, and you can see I've already created a list called LAN list. So to create a new one, just go on there, just give it a name. Once you've done it there, you can then add interfaces to your list. A bit like when we did with the address list, instead of adding addresses, we're adding our interfaces. So what I've done is I've added those two VLANs to our LAN list. Okay, then we go back to our firewall now. So when we create our deny rule, we can say anything coming in from our LAN, coming out of any of our other LANs. This won't affect any traffic inside that VLAN. So anything on 192.168.20. Something, because that all happens at layer 2. So it doesn't actually touch the firewall, it doesn't actually touch the routers at this point. That's all happening at a frame, Ethernet frame level, MAC addresses. So yeah, I did kind of touch on that in the first VLAN video I did. But yeah, certainly worth getting your head around. Certainly the ISO 7-layer model. For troubleshooting, it's a must, I think. And it just helps you prioritize what you look at and where you start looking. So we start at level 1, 2, 3 onwards. So anyway, we won't go too much into that. So this is our forward blocking one, and then we're going to drop. Okay, and we apply that. So my internet traffic is going out of this interface, and because I haven't included that in the list, it should mean that I can still ping the internet from these. But in fact, it's always best to show you it working before I break it. Let's disable that. Let's ping 192.168. What am I on? I'm on 1, so 30.252, I think was the IP address. So I can ping the host on the other one. Now if I go ahead and enable that rule and try to do that again, there you go, so it stops. Okay, so that's my explicit deny rule. What we're now going to do is add those accept rules. So let's allow ping between both networks. So again, forward protocol this time is ICMP. We'll just do LAN to LAN and accept this time. It's above it. No, it's not. See, look, that's a bit of a, I've sorted somewhere. See, I've sorted on that chain there. So you see that little arrow. So yeah, that could catch you out. Don't think that's in the right order. Click on that. There we go. The wrong way around. Move that up there. There we go. So we should be able to now ping. So I can ping again. But for example, if I try an RDP to it, it'll fail. Okay. So now I want to allow RDP, but I only want to allow RDP one way. I want to be able to RDP from VLAN 20 to VLAN 30. Okay, so what I'm going to do is add in another rule in the forward chain, and we're going to go from this time not from the lists, but we want to go from. So we could do it from the list, and we could do it based on IP addresses, but so this time we select the interface being from VLAN 20. And then we go, the destination is going to be VLAN 30. And the protocol is going to be TCP, and we want to do 3389 for RDP. Action accept. Okay, now we add that above. Now I will show you it will still fail. Okay, now you may be thinking, okay, why? What's wrong? I can see the traffic's hitting it, but this is a little neat trick for troubleshooting. When you set the action, you have this option, hit a log, and then we can give it a prefix, so we'll just call it drop forward. Obviously don't leave this on all the time because it's going to fill up your logs pretty quickly, but it's a good troubleshooting tip. So then what we're going to do is load up our logs. Let's just make that a bit bigger, and let's attempt that RDP again. Connect, and while it's doing that, there we are. So user 2, so coming from VLAN 30, going, so it's the reverse that's getting blocked. So obviously my traffic's going out, but it's coming back with connection state established. Let me just make that a bit more, to open that one up itself. There we go. So basically the return traffic is getting dropped because we're using TCP, so there's a handshake involved, and it's coming back from that source. So what that means is we would need to then create another rule. We can copy that one, but we then just need to reverse these. Okay, and then we just need to change the destination as being the source to that port. Because if we look here, the source is that port 3389. So you with me so far? Okay, so now I've got basically a reverse of the one before. Let me try that again. There we go. Now it gives me the login prompt. However, okay, so that works. That's all well and good. We shouldn't be able to get to it the other way. If we do 192.168.20.2. Okay, so we still can't get to it the other way, which is what we want. So we've achieved what we wanted to do. However, as I mentioned before, I like to keep my rules as small as possible, so it's easier to troubleshoot, easier to add and remove, and basically keep a good control on your firewall, because stuff can easily, if you then, for example, I've done it before where my ISP is, I've changed ISPs, and instead of being a static or dynamic just an IP address from the modem, it's then changed to PPPoE, which is a different interface. So I've then had to go through and change lots of extra rules. So I try and keep the rules as small as possible and as neat as possible. So we're going to get rid of this rule because I don't want too many. Now, if you remember in here, we had connection state established. So if you see my firewalling video and on my input chain, I like to do, again, if you've got something that's coming out, being established from your router, like NTP or DNS, so sending out a request, it's going to deny the return because you haven't allowed DNS on NTP, and then you don't want to be opening up DNS to the wide world. So what you do is this connection state here, you basically say established, but you want to invert it, so you want to say not established. So bear with me, it's going to be anything that's coming from these two networks but that isn't established traffic is going to get dropped. So if it gets an established packet back, i.e. it's already got an outgoing connection which has been allowed, then it will allow that traffic back in. So when we apply that, and this will work for anything, so we just have to have this single rule. We don't have to create the reverse every time. Try that again. Which machine am I on? Well, yeah, this should work. There we go. So that's going to work to there. But then if we go onto our other machine, we should still be getting no joy. Okay. So hopefully that's clear enough. Other things we can do, we can limit it to individual ranges. So if we wanted, we knew what we say this was a terminal server I'm trying to RDP to, we could specify its destination address here. We could do it as an address list, which is always my preferred method if we're likely to have multiple ones. But you should get the idea by now. You've got all these different, so this general tab, this is where we're going to do most of our matching of our traffic. We have this advanced tab where we can do even more. Previous versions of Router OS 6, I think the address list part was under the advanced tab, whereas that's now moved. We can go right down into types of ISP policies, any times to lives, things like that. And then obviously the action is where we set what we wanted to do, but for us we're only worrying about accept or deny. Okay. And that log feature is available on any rule. So if you're wondering why certain traffic isn't being allowed, you want to see if it's actually hitting the correct rule, so you're matching correctly, just log it, give it some name which is easily identifiable, and it'll put it at the front, and it'll tell you all the information about it. So it's the forward chain, where it's coming from, where it's going to, the connection state. It will see its MAC address, and as you can see, the protocol is TCP, so it was an acknowledgement going on there. Okay, so hopefully that's all clear enough. But yeah, please comment, leave me any feedback you've got. Always happy to work for any problems people have, any particular videos people want making. If you think I've missed something on this, or you do it a different way, I'm not perfect, I don't know everything, I just try and make videos which I think are the best way of doing a certain thing, from experience or from what I've learned. So please let me know your thoughts, and thank you for watching. Please like and subscribe as well, makes a big deal, and if not, I'll see you on the next one. So thanks.